know that. It was so lonely over there.
Yeah.
You can press the hide button.
No, the worst
from there.
student in the class. Like they usually sort of paper teacher.
It's also on YouTube.
It's also on YouTube. Oh,
Like the white country or what?
I'll hang out on air.
So basically,
yeah.
You like
the
that?
systems that we have now,
Actually, it's recording.
Is that
so no big
how
emergencies. And they work unlimited. No.
spastic?
I know that.
Yeah.
You can press the hide button.
No, the worst student in the class. They
Through your phone. That's us.
sort of paper
We
teacher.
need to add how it's
I just did it as a delay.
Also on YouTube. Oh.
Everyone's afraid of it. So basically,
Yeah.
the systems that we have now,
Hello.
and work unlimited. Happy kids.
Max, are you guys on Wi-Fi or network?
We're on the network.
Everyone's afraid of
Is that here? I see 4 here. All right. The other issue is
Us.
All that noise is
All that
on.
noise is
You're
up.
familiar with the Lolo.
Because Max is very on his, or no, it's through microphone.
I have to.
it's showing the screen.
Okay, we're gonna start, guys. Guys, before I start, I want to thank again, Kaufman, Rosen, and company or funds, Daryl, Edson, Nestor, Max. Thank you so much for helping me or let me host the meetup. So once again, obviously it's going to be in continuous delivery. My name is Marcelo Olivas. I work for 3C Interactive. I'm an architect over there. Basically, what that means is that I'm responsible for the software architecture of the application, make sure that it's sound, it's scalable, maintainable, is resilient, but at the same time, we want to make sure that, you know, we're able to deploy it, make sure that we're able to monitor if something is wrong. We need to, you know, really quick recover from that or fix it right away. And that actually got me into the continuous delivery. Before we start, one of the things that I'm going to ask you is, I have a lot of slides, even though I worked out with Edson and Daryl. The problem is that the continuous delivery spectrum is huge. It's really big. So one of the things that I'm going to ask you guys is to hold your questions until the end, because there's a lot of things that we would like to cover, that I want to cover, I'm sorry. And obviously, you know, I want to make sure that we leave here in a set of time. Last time I tried to do this run, it took me like about an hour and a half. So let's see. So before anything, I want to start with this picture. Oh, you guys can probably not see who that guy is, but it's can you see him?
Is that Eric Reese?
No, actually,
Oh,
this
Can you
is
see
Simon. I think his name is Simon Sinek. He ended up writing a book that it's called Start with Why. Basically, one of the things that you know is a lot of most companies, right, understand why what they need to do to be in business. Few companies know how, very, very few know why. And one of the things that you want to do is always start with why. And the reason why I put that in there is because once you start talking about continuous delivery, in reality, you're talking about effective engineering practices. That's ultimately what you want to do. Once you start doing, once you end up going through all this stuff, you end up finding out that all these practices really just get you to better effective software, right? At the end of the day, the mantra is for, what is the best code? The one that you care to use, the one that you effectively are using and doing and making sure that it's sound and is basically suiting the needs of the company. Having said that, right, the business needs, are bigger than the operational constraints. What that means is that I believe, right, that putting governance on doing deployments and putting some type of procedures for doing deployments is pretty bad. And here's why. This is the way that I end up seeing it. On my job, right, one of the things that we end up having is we end up finding a bug that was costing us about $5,000 per day. And the moment, the fix was really quick. And once I put it in there, then basically they told me, okay, you need to put it into development, then it goes to QA, then it goes to UAT, and finally it goes to production. Anyways, we end up putting all of that there. But by the end that we end up putting that on production, it took us 2 weeks. So that to me is just terrible, because even the business was telling me, look, did you fix it? I'm like, yeah. How come it's not in production? I was like, well, because, and then you start explaining things to them and they really don't care. So again, it's because of the fact that with governance, and again, one of the things that we have in our company right now is governance. I was having this conversation with the guys upstairs. But one of the things that we have is, for example, we only do deployments on Tuesdays and Thursdays. We don't do any deployments on Fridays. Why? Because we just don't. And that's terrible for the business, and really you don't want to know. And the other thing that you end up getting is quick feedback, right? Once you end up doing all this, once you start doing all this stuff, you end up getting quick feedback to find out if it's fine or not, right? So I'm going to start how we end up here. I talked about this with Edson, and he actually told me to remove that, and I'll explain why. At the very beginning, when Edson and I got introduced to the whole agile world, one of the things that they told us was like, I know that we have all this waterfall, but this is going to solve all your problems. We're going to get the customer, right? And then after that, we're going to get a team that is going to do the analysis and design. And then after that, we are going to get a team that is actually going to do the development. Once you finish that, right, we're going to do the testing, and then we're going to show it to the people. And it's going to be awesome, and we're going to show it to the client, and everything's going to be fine. We're going to have iterations, right? And everything is going to be phenomenal. And it's true, once we end up getting this part, sure enough, we end up getting a binary. It's ready to go to deployment. But before you go to deployment, you need to give it to the integration or the QA. So the QAs take it, they have to spend some time, make sure that everything is great. Because at the end of the day, they are responsible for getting the application to production. Which brings me to, then you give it to production. So these guys are the ones that are going to do the carrying and feeding of this application. So guess what? This is considered the long mile, because this is the one that ended up taking the longest time. And if you really think about it, we went back again to the waterfall. Because, yes, you're doing something really cool over here, right? And you're keeping iteratively, finding out and doing all that stuff, but then you're pushing all this stuff over there. And it takes forever, and this is why Edson didn't want me to put the agile here, because it's true. It's not longer like that, right? We shouldn't be doing like that. One of the things that we should be doing is getting a customer. Notice that I do a product team. One of the things that I'm going to talk about is we end up having, in my company, one of my biggest problems that we have is that we have project teams. It's like, Marcelo, we have this project over here and blah, blah, blah. Then all of a sudden we start doing the project and we're doing it and everything is great. After they end up leaving, guess what? Then no one knows what happened to that project. One of the things that I end up getting this from is actually, I have a few of my buddies that are working in Amazon for a product team. And that product team is always there. The entire team is there. which when I said the entire team, is that everyone is in there. If you remember, this is the development, QA, and prod. All of them are doing the integration. So time and time and time again, they just go into this integration, right? And at the end of the day, the one thing that you get is the constant flow of features that are going into production. So here's the holy, and by the way, this is what a lot of people are calling nowadays DevOps, right? But in reality, it's a bunch of, best engineering practices that we end up learning, and we are basically applying it. So to me, the way that I see it is basically a job done right. So the holy grail for continuous delivery is, software is always in a production ready stage. So you deploy it, you make sure that you have some sound testing there. You have a lot of stuff in there, you have a lot of metrics, everything is done right, so it's ready to be on production. The other thing that you have is deployment are reliable and in common place, meaning that you don't have to dig in for someplace. And the other thing that I hate is, this is something that was common in another company. We'll go through the different phases, right? So all of a sudden they end up finding a bug in QA, and then someone come over there. I was like, oh, that's a really quick fix. Let me just get you another binary and just put it there. And that is actually not that kind. The other one is everyone can self-service deployment. And this is happening actually in my company. One of the things that we have, it seems like you have to get a developer, a voodoo doll, and a live chicken to get anything on production. So we're trying to get away from that, and we are. And it's been some a little bit of tug of war, how I call it, but we're moving towards that. And that's the other thing that I want to tell you. Right now, we're not fully into continuous delivery. We're moving that way, but basically one of the things that I wanted to show you, some of the things that we end up doing, things that end up fading, and hopefully you guys can learn from us. And this is the last one, which is release according to the business need. So again, there's a bug, it's costing us $2,000 a day. Just put it on production. Obviously, you cannot get continuous delivery without some type of prerequisites. And this is something that ends up biting me in the butt. Comprehensive. Sometimes I end up putting something on production, and then I get a call. My friend Larry Long, I call him LL, not to be confused with Lady Lover, but I call him LL. So Larry calls me, he's like, Marcelo, I'm like, what's up, LL? He was like, dude, I'm getting calls from clients, and I don't know what's going on. I'm like, what do you mean? Well, I get this no pointer error, but I see that no pointer error everywhere. And I don't know if that's the error. I'm like, I have no freaking clue. Let me go look into the code. And that's what I'm comprehensive. Every time you deploy something, everyone knows what the heck is going on. You don't wait for a guy from system because they have no clue. Like, okay, I see a no pointer exception. Is that an error? Is that something that I need to take a look at? What should I do if I get the no pointer error exception? Should I stop everything? Should I not? So that's what I mean when I say comprehensive. The other one is configuration management. Everything has to be configured according to what you have in production. So that's something that you need to make sure that you end up having, whether you end up using Puppet or Chat. Basically, you just have to use it. Continuous integration. This is something that a lot of people are using nowadays. Even though, like Edson told me that he's been on some shops that they don't even have that, but you need to end up having continuous integration. This is, for me, the moment that I end up finding out that a shop doesn't have continuous integration, that is a big red flag for me. And the other one is metrics and monitor. For me, this is the yin and yang. Metrics and monitor, you cannot get away with this. This is borderline irresponsible if you don't have metrics and monitoring, in my opinion. Finally, excellent automating testing at all levels. One of the things that before you even get into the continuous delivery or continuous deployment, we'll talk about the differences in both, is the fact that you have to make sure that you have to have a very high level of confidence on whatever you put in production. So this is what I mean by excellent automated testing at all levels. Clearly we have way too many acronyms in our field, but one of the things that now we have is like continuous this, continuous that. One of the things that I want to clear out right away is the difference, right? So you have continuous integration. And usually what you end up having is every time you end up doing some type of code in your code repository, right? It fires off into this machine, and the one thing that it's doing, you basically end up running all your tests, all your unit tests, or your integration tests, to make sure that the tests are sound. And then after that, right, it probably puts builds the binary, puts it in one place, and it's ready to be used from someone, right? So that is continuous integration. One thing that you end up having over here is if it fails, if the continuous integration fails, then you fix it right away. And then we have continuous delivery. And the continuous delivery is, you end up having the continuous integration. So you end up doing a code and stuff like that. And you end up going through all the tests and everything is ready. We put it in the code repository. But then you basically have a person that says, okay, you know what? I'm going to give the okay. I'm going to be the one that is going to push the button. I'm going to be the one that determines when this goes into the production environment. Whether that's UAT, in our case, for example, is the clients, the ones that are saying, okay, everything's okay, put it on production, or whether it's QA, right? And so as you can imagine, that's like a pull. And the difference between that pull and the push is the continuous deployment. On the continuous deployment, right, one of the things that you end up having is you end up doing a code and it just goes straight to production, right? And again, three different things. These two depends upon your company. For example, I know a lot of people that end up using, in our case, there's projects that end up using continuous deliveries. There's some other projects that we're getting into the continuous deployment. In the continuous delivery, mainly there's some stuff in there whether the client wants to just validate, or for example, we end up doing a lot of credit card transactions. Sometimes what we have to do is compliance have to go over there and just make sure that everything is great. I've seen this a lot also, like for people that end up doing a lot of compliance, a lot of public companies end up implementing this as well. And then I'm going to talk about the different topics. I told this to Daryl and Edson. I'm trying to see if I can divide the presentation in two sections. Deployment pipelines. One of the things that I want to talk about is the different pipelines and different things about tests. What are the tests, and some of the practices that we end up learning. Finally, deployment, infrastructure, and data. So in deployment pipelines, one of the things that I'm going to show you over here is some of the pipelines, how they look. This is going to be very much according to the business needs. So in deployment process, right, one of the things that you end up having is, first thing is the commit stage, right? This is the moment that you end up doing some type of code. It goes into the code repository, boom, it goes in there, right? Then after that, you may probably have some type of acceptance testing, right? Whether that's like, probably QA, testing some corners, or, basically you're getting this binary, put it in some type of machine, and then fires off a bunch of unit tests. I'm sorry, user acceptance tests. And in our case, we have some SLAs that we need to meet. So we do some automated capacity testing. In other words, we build another machine, and after that, we're going to say, okay, I need to have at least 2,000 messages per second. So we just fire that, and we make sure that everything is fine. This is the manual testing. Again, this is depending on our application. Sometimes it's a UAT, where actually the client ends up testing in that place. Or sometimes it's just like, investigation that some people end up doing. And finally, the release. Right, and again, the one thing that you end up doing is you want to basically increase the confidence in your production. So now one of the things that I'm going to do is I'm going to take my magnifying glass and go through each one of these stages. We're going to start with the commit stage. Again, this is pretty straightforward. You end up having a version control. Then after that, you end up pulling from that every time you end up making a commit. You go into the stage, and again, you do the compilation, the unit test. You assemble your code, you package it, you do some type of code analysis. In our case, we end up using Sonar, and then you end up deploying it in some type of repo, right? And this is something that a lot of people end up using. And again, this is something that we always know. We run against every chicken, right? So we always end up, every time you end up doing a commit, this process gets kicked in. And after that, it creates a release candidate. And finally, right, if it fails, right, we all know what we got to do. Whether you get like, the dead chicken in our case, we end up having this chicken, rubber chicken, and we give it to the person who ended up breaking the bill. Back in the days, Edson and I, we used to have like a little siren. Remember Edson? It was awesome. And so now we go to the acceptance test. And here, if you notice, one of the things that we have, right, compared to the previous one, is this guy. We end up having a configuration environment, right? So this is, from this moment on, we start mimicking how your production environment is going to look. And as always, right, very similar, is end-to-end test on our production-like environments. And at the same time, it triggers when the upstream stage passes, or in other words, if the commit stage passes, boom, it goes to the stage. And finally, similar to the previous one, if it fails, you fix it, right? And then we go back to the manual stage. And in the manual stage, again, the difference is, if you notice, everything is the same, except that in this phase, someone is holding that trigger. Someone is actually saying, okay, I am going to be the one that is going to say when I can tear down this machine. And but again, we go into the UAT staging and integration, even on production. But again, the deployments are self-server through a push button process. There's no need to get in, like everyone assemble or one person in charge of this stuff. And this is how basically we envision to have, our infrastructure, or the way that we end up envisioning our different stages, right? So in the commit, basically, is the realm of the developers, right? We want to make sure that we end up seeing the metrics and the test failures. We want to make sure that we are aware of it. In this acceptance stage, right? Again, are the testers, and obviously, finally, is on operations, right? Those are the ones that end up putting everything in production. And one of the things that I want to make sure is that I make it actionable, right? These are some of the one thing is, obviously, if you notice, every one of these guys end up having that configured environment. This is something that you basically need. The moment that you end up going away from the commit, that you are basically taking the responsibility of mimicking as much as you can the production environment. Again, one of the things that I wanted to see, or actually one of the requisites that we have in our team, is actually be sort of like scouts, where we end up basically finding out different tools that we can use to end up having a continuous delivery. Here are some of the ones that we end up reviewing. We did not end up using Go, although a lot of people basically swear by it. I'm a fan of ThoughtWorks. Edson and I work with a couple of people from ThoughtWorks. ThoughtWorks end up creating Go. One of the ones that we end up using is Bamboo, just basically because we're an Atlassian shop. And so we end up leveraging a lot of the functionalities that the whole Atlassian suite gives us. But before, we used to use Jenkins. And we're moving a lot into the cloud. We are looking also into AWS pipelines. One of the things that I'm going to move forward is now some of the anti-patterns that we end up seeing. One of the anti-patterns is insufficient parallelization. You end up having all these different stages, and most people, at least in our case, we end up having one machine, right, that end up doing all your builds. In reality, the moment that you end up doing the compilation in here, there's no reason why these guys cannot be parallel into different machines, right? The one thing that you want to get is really a quick feedback. So imagine if something is going on with, like, in our example, Nexus was just growing exponentially. So it's like, everything passed, but then all of a sudden it's like, boom, Nexus is out of space. Oh. So then if you find this out really quick, it will be awesome. So that's one of the things that we end up doing in Bamboo. End up implementing phases, what they call. The other one is inflexible workflow. It's the fact that imagine that you have all these tests and then you need to have some manual approval in all these places. Again, this is as the way that I end up seeing this is basically as per application. So in here, one of the things that you can end up doing is basically fan out. So, the moment that you have the commit stage, you can actually end up doing all these guys in here as well. I want to talk a little bit more about the testing. One of the things, and this is something that I end up talking to Edson, at the very beginning, everything for us was a unit test. And then eventually now we're breaking it down a little bit more. The other thing that I try to force in my team is, trying to envision like the difference of automation and also speed, right? For example, unit tests. Unit tests, you have a lot of unit tests. And these are the unit tests, these are the type of tests that are completely automated. Completely automated, and at the same time, they're fast. They're there for, the sole purpose. If you do some type of refactoring, you want to make sure that nothing is broken. But, again, 100% automation, and they're fast, right? The functional acceptance test is a little bit different, right? Yes, they are automated. The one thing that you have is that now, instead, you want to get it as close as possible as you have in production. So whereas over here, you can end up using some type of embedded software, over here, you want to not use that embedded software. So for example, over here, you can probably get away by using H2 or Hypersonic or any of that. But over here, you probably want to use the closest thing as possible, or at least a MySQL or something like that, similar to that. What I'm saying is that it will take a little bit longer. Then you end up going over here in the manual part, showcase, usability, testing, exploratory testing. This one will be manual, right? This is when you're doing some sort of like you showcase it, or you're talking to a client and going through all the stuff. It's manual. The non-functional acceptance test. This is some of the tests that we end up using with or QA. Or in QA, the one thing that we're getting them away from is instead of testing the whole thing out, we just tell them no. You guys are going to take care of the little dark corners that we have over here, and that's it. So again, most of the stuff that we have is automated, but the moment that you end up going over here, right, QA has some type of automation scripts that they have, but there's some of them that they have to do it manually. The other one that I want to talk about is something that we're talking about also that's in there. Basically feature branching versus Trump-based development. And I did a terrible job when I explained it to the guys. I haven't shown you this slide, so see if this makes sense, right? Let's say, for example, you have a branch, right? And here I did a couple of commits, right? This is great, and one of the things that I want to do is obviously feature branch. We're using Git, and we also end up using Git flow. So you're familiar with that. You know that every time you end up creating some type of feature, fixing a bug, you always create some type of feature branch, right? In this case, I'm going to create one, right, where I'm going to create a feature, and then I end up doing some type of commits, right? But at the same time, someone else is also doing another feature, and they also end up doing a couple of commits, right? This is basically in the same day, so I end up doing a commit, right? And then I push it, and I know that there's a little merge going on, and then basically I do the same thing. It's a small little merge, right? But now, imagine that you're doing something a lot bigger, right? I don't know, like maybe you're trying to get some type of computer science algorithm, better search engine, or just trying to get something going, right? For something that is taking a lot longer. So in here, let's say, for example, that this someone else is doing some type of feature, and in this case, it's taking months. And at the same time, I'm doing some type of features that is also taking a lot longer. Right in here, I'm doing a lot of the stuff that I'm doing for computer science. I'm trying to see if there's an algorithm that I can end up doing over here. And then in that one, they're also doing some type of searching, and they're probably end up using something like Elasticsearch or something like that. And then finally, someone says, you know what, we really, really like that Elasticsearch that you're using over there. Let's go and integrate it. So they integrate it. And then after that, they say, Marcelo, how's that going with the, with the logic that we end up giving you? And I said, so far, so good. It's like, perfect, bring it in. Then after that, you have this ginormous merge that you have. And this is a big problem because one of the things that you end up having here, right, is the fact that now, let's say, for example, I have a customer class, right? If two people are having that customer class and I edit it and they edit it as well, then the moment that I merge, I'm like, what are we going to do? Should I use that because this is part of my features and this customer class are also part of your features? So then you start thinking about duplication and stuff like that. So it gets really, really nasty. And that's the difference between the feature branching. So one of the trunk-based development is everything is in the trunk. Everything is there. So the other thing that you have in here, the moment that you end up getting with these feature branchings that are taking a long, long time, you don't want to do much refactoring. Because if you do some type of refactoring, you're going to affect, this ginormous merge that you end up having. So the one thing that you end up having now is everything is in the trunk. But then imagine if all of a sudden, someone says, you know what, I really only want to see the blue feature rather than the green feature, but I want to turn it on and turn it off like that. I can show it to the client, right? There's a way that you can get to that, right? And one of the things that you end up having, right? First of all, let's talk about the problems that you end up having with this model. One of the things that you have is, you want to make sure that you end up integrating continuously, and you do the same continuous integration into the developer trunk. The feature branches, yes, there's separation of features in branches, but the one thing that you want to avoid is this big, huge merge that you end up having. And so one of the things that I mentioned is the trunk-based development. And the way that you end up turning off and on some of this stuff is by using toggles, right? And actually, this I learned it from Daryl. Like you mentioned that in the previous in the previous talk. So toggles is a great tool. We've been using it a lot, and we really like it, especially because there's a lot of stuff that you get into it, especially the way that you end up doing deployments. You can end up getting like some type of GUI so the sysadmins can turn this off and on. So it was really nice. The other thing that I want to talk about is incremental release strategies. I want to talk a little bit about the blue-green deployments, canary releases, dark launching, and the production immune system. So in the blue-green deployments, right, let's say, for example, you have these different servers that you have in there, and now you want to release a 1.1, new bug that you find out. So one thing that you end up having, right, and in here is the server, but in reality, if you're in the cloud, like many people are, this can be different machines in there. So one of the things that you rely on is your load balancer. One of the things that you end up doing in the blue-green deployment is the moment that you end up deploying all this stuff, right, the load balancer, the one thing that you can end up doing is, you end up deploying all the new version, and then after that, you gradually end up making sure that these guys, let's say, for example, a 1.0 for the web, they consume, you get all the session, you dehydrate all the sessions, and then after that, you start migrating everything to the green side. Again, over here is to avoid any type of downtime. So in here, right, you basically have two servers, right? Let's say, for example, you have one server that is with the 1.0, and then two servers that are with 1.0, but you also have the 1.2 in there. So like let's say, for example, you turn off this one with the 1.0, you put it with the 1.2, and then you make sure that all the sessions get relied, so only this guy is being touched. Then after that, you put this one with the 1.1, and so now you turn this off, and everything is going to the 1.1. So One of the things that we so we do this a lot in many, basically all of our applications. But we also end up doing canary releases. And the canary releases, we end up using it mainly for load test. The reason for that is we have some pretty heavy SLAs where we end up doing like about 2,000 messages per second. So the one thing that we end up having is, again, we put one of the servers outside the cluster, right? And so we have a smoke test machine over here, and we just start firing out, actual user acceptance tests or just smoke tests, just see how it behaves. And then once we're okay with that, the one thing that we end up doing is we gradually just put a little bit of traffic in there, and then eventually we'll start seeing how that's behaving. Actually, this is done a lot by Facebook and also Amazon. One of the things that Facebook does is every time they have a new release, they get a very small percentage of the population in New Zealand, right? And the reason for they choose New Zealand is because it's the first one that they get, the new day. So they end up finding out how they're behaving in there, and then after that, they gradually make it bigger and bigger. My friends in Amazon, they end up telling me something really cool. They were saying that at any moment in time, they do deployments every day. And one of the things that the marketing department end up doing is that they deploy something, and the moment that they deploy, they end up looking at how the people are interacting. So in other words, they just get like a very small percentage, and they find out, how are the people reacting with that type of feature. And if everything is okay, then they make it bigger and bigger and bigger, right? And then if they need to adjust, then they either remove it or they just let it be there to get more feedback. But again, one of the things that you end up having over here is no downtime and just continuous cycle. One of the things that we learn really, really quick, and the reason why we end up implementing a lot of health checks and a lot of that, is imagine that you have a continuous delivery. Everything is okay, and every time the developer ends up making a commit, it goes straight to production, right? This is part of that holy grail that you have. Now imagine that for whatever reason, one awesome guy, right, end up replacing the Bible with the Pro JVM, right? And all the tests pass, everything is fine, right? So you end up going on production, right? And all of a sudden you notice that your sales are plummeted because no one can find the buy button, right? And this is, again, remember the yin and the yang. One of the things that you need is metrics. I cannot emphasize this enough. If you don't end up using metrics, it's bottom line irresponsible. One of the things that I end up using, as Mr. knows, I'm a big fan of not using graphite. We use Core Health in a lot of our code. We end up using a lot of stuff also for Hystrix, as I mentioned before. I know a lot of people end up using StatsD. Sensu is something that we're really looking forward to it. I think I really like Nagios because it's in my bacon in a lot of times, but Sensu is a much better product in my personal opinion. Right now we're using also New Relic in our company. What else? The other thing that I want to talk about is databases. One of the things, my first language was PL SQL. So I have a special place in my heart for databases. But for me, when I started working with databases, that was 1998. And it seems like nothing has changed. Like nothing really. If I go back again to, the tools that I ended up using in 1998, basically they're the same. Especially if you end up doing like PL SQL like myself when I was using Oracle. One of the things that you have, and this is something that pisses me off, every time I end up doing some of these talks, they were like, Marcelo, that's fine, Dan, all those things, you can, servers come in and tools come in and go, but the reality is that my schema is precious. And I don't think that's true, because if all of a sudden, one of the things that I tell people is that, today, go and print out your ERP. And then after that, once you put it in all these, humongous board with all your 50 different sheet of papers in there. Imagine if you want to do this from scratch, will it look identical like that? And it doesn't, right? But one of the things that we want to make sure is how can we do continuous integration for databases? And I ended up stumbling on this book that I think is called Database Refactoring. Such a great book. I ended up getting a couple of patterns that we end up having. And because again, one of the problems that we end up having in my company, we end up growing really, really quick. And one of the anti-patterns that we end up using, one of many, is actually the integrating all of our apps with our database. So when I got into the company, I was in charge of actually building a transaction gateway for credit cards, and we did an amazing job. We changed a lot of the things in the database, so then when we were ready to deploy, I was like, this is perfect, we're going to deploy it. We tested it, we have all the smoke tests and everything. Once we deploy it, they were like, you need to roll that back. And I'm like, what happened? It was like, well, like 5 of the applications are not working. I'm like, how can that be that they have nothing to do with transaction gateways? No, we all integrate to your database. And you change the schema, so we can't do that. And I was like, what? So one of the things also that we wanted to find out if it was something that was with the continuous integration. And we ended up finding this one. The DB deploy pattern is actually started in Ruby. Ruby ended up implementing something like this, and the cool thing about this is the fact that the moment that you end up doing some type of change, the change is actually saved in the database. There's actually a schema that has all the changes. So every time you do have a change, if you need to roll back or whatever, right, this guy's automatically knows like, okay, this is version 1, the blue guys, and then this version 2, the red guys. So if you need to do some type of rollback or deploy or anything like that, he already knows. So one thing that you end up having is, again, this continuous integration for databases every time you end up doing the deployment. And the type of tools that we end up looking in here is Flyway and Liquidbase. We are a big shop of Spring as well, so we end up using Spring Boot a lot, and they're integrated into Spring Boot as well. And again, some of the things that you end up getting with this pattern, you apply migration, you do the DB updates as code, and small increments or small deltas, metadata is in the database, and if it fails, you end up getting a quick feedback so you can revert it or do something like that. So again, one of the things that I noticed a lot of people that are doing continuous delivery or in the continuous integration, either they start with a brand new database or they nuke and pay the new one. And this is something that we've been working on a bit because in some applications they're very small. So it's very easy for us to just blow it up and then just put the MySQL dump. But for example, in transaction gateway, because there's a huge amount of transactions that we end up doing in credit cards, some of the tables are too big. So one of the things that we end up using is just creating the deltas in there. So that's one of the things that we end up using. And then number 5, once we end up going to production, we just give the DBAs so they can apply the deltas in there. And this is the book that I was talking about. Good book. One of the things that we also end up doing is the dark launch database update. So let's say, for example, if you end up having some type of deployment, one of the things that I tell people is, if you know already how the schema is going to look, and you try to make it backward compatible. In other words, if you want to add another column, just have the DBAs add that column already. And once you put your application in there, it's already there ready to be populated. One of the things that I ended up doing in the project that a lot of people were using the database, so instead of having these reports or these applications going directly into the database and creating one of these joins, we end up leveraging views and stored procedures. I'm not a fan of stored procedures because, as I mentioned before, I was basically a data warehouse. We were doing a lot of data warehouse, and during 1998, a lot of people were leveraging the database to do most of their business logic. It was expensive to go into the database, so you put all the logic, all the domain logic into the store procedures. It's incredibly, it's hell to manage. So I'm very skeptical of using store procedures, but in this case, if you need to like sort of like decouple the integration pattern that I was mentioning of people using the database after integration, you end up telling them, look, just use this view. In the case that you need to change, you just make sure that the view works. So like that is working. But I'm not going to sugarcoat it. Deployments, DB deployments are still very hard. One of the things that we end up getting is a lot of practice in politics. Unfortunately, in our case, the DBAs are still a little bit reprehensive of doing any type of changes like that. They just hate it. They just straight out say, look, stop it right there. You're messing around with the wrong people. You take care of your servers over there, do your deployments. We take care of the database. So leave us alone. And this is one of the things that we're struggling, to be quite honest with you. And again, this is the part that we say about the politics. Sometimes, it's better to have someone to come to the top down saying, or the way that we put it is we end up doing another project where, the database was so small that we end up doing continuous delivery. And everyone was like, this is perfect. And then it was like, how come you cannot do just all those bug fixes and all the features as quickly as possible in Transaction Gateway? I was like, well, because of the database. I was like, what do you mean? Well, the DBAs don't want me to do these changes. So then they go over there and they're like, I want the changes. So that, that type of pressure into the DBAs are allowing us to get a little bit more penetration, so to speak, to the continuous delivery, but it's still very hard. And again, one of the things that I want to do is fail fast, and make sure that the DB encoder are dependent. Again, going back to the slides, if you remember, you have the gray, the green, and the red. Everything has to go together. One of the things that we have, that we still have a big problem in the company is operations. And they truly have a horrible job. Because one of the things that they do is they deal with legacy apps, heterogeneous platform. Most of the time, they have no idea, right? We end up doing this refactoring of this application from MySQL to Cassandra, and the poor guys were like, I don't even know what Cassandra is, right? And there was a problem in there, and they were like, dude, I don't even know what to do now. I'm getting errors, but I don't know what that means. The other thing is you end up having crappy software thrown over the wall. Before this was a lot like that before. And, and this is one of the things that we're trying to get away from is this. Most of the time they're firefighting, and this takes a lot of toll on them. And this is why they become conservatives, process heavy, and then they say, no, we just got to manage. We're going to put a bunch of process on you because you guys are making us sort of life and living hell. And this is something that I got. 80% of the IT budgets is spent on ops. And again, it's just one of the things that we end up, we know what we have to do in our company is, the whole DevOps, right? And in here, you're no longer working in a silo. Basically, it's again, we're working as a one team, right? From the very beginning all the way to the very end, operations are with us, right? From the moment that we start all the way until we end up showing the showcases and the retros, they're there. And one of the things that change our mentality is this: the developers work in operations and are on call. The reality is the moment that we end up having this, our logs look a lot better. It's no longer more a log saying, yeah, this guy entered the sell process. This guy finished the sell process. It didn't tell us anything. Now we know like which cell ID is coming in there, which cell ID and finishing. So one of the things, the moment that you end up doing this, you end up seeing a lot better logs. And one of the things that you end up having is you want to create more software. And some of the things that we also find out is the moment that you end up having the devs work on the call, if you end up releasing something, like in my case, I released something and it was creating a bug in the morning, I know for sure that there was someone in the morning pretty pissed off at me and was one of my teammates. So, you just have to be aware of all that stuff. So it made us a lot better of a team. Managing infrastructure. This is something that you need to do. That's it. That's the bottom line. The way that I told this to the ops team is, if I end up pointing at two servers and I tell them what's the difference between those two, if they have to SSH into the servers to tell me exactly what is the difference, you fail. You should just go into some type of configuration, right? Get the diff and find out what's the difference of those two, right? And this is one of the things that we end up getting. Infrastructure. So one of the things that we want to make sure is that besides the specified versions of Nomic, there's no. One of the things that we were talking about the other day is there's no. Before it was like there was a guy that knew exactly how to configure the database server with this stuff, and it will make it, this state-of-the-art servers. Not anymore. You can destroy a server and you can put it up by just, in our case, we end up using Puppet. So infrastructure as code, everything is in some type of code repository. You're able to do refactoring. You're able to do testing. You apply it to the build pipelines. If you remember in the stage, in that case, not only you bring the artifact that you're going to deploy, but also you end up bringing the smoke test as well as the code to build the machine and self-documentation. The one thing that I end up finding out from a lot of people is that sometimes your compliance comes over and they were like, oh, are you IPC compliant or Sarbanes-Oxley compliance? And one of the things that they just get the recipe for the chef or the Puppet configuration, and then basically can give you the thumbs up because you're in compliance. Again, one of the things that we're using is Puppet, and we manage many of the system configuration, system consistency, and obviously we treat infrastructure as code. The other thing is we try to deploy all of them the same way. Again, we try to separate things that change for things that don't. This is something that, again, we try to break away from the whole mentality of I am the one that ended up doing the database. Now, not anymore. We end up finding all the configuration is there, and if you want to build a server with for the database server, that's it. Virtualization, we use it a lot, especially in the different stages that we end up having, except we're still moving everything to the cloud, even though we do have some type of footprint into a data center. We are in Boston right now, but we're leveraging heavily on the virtualization. We're AWS, and we use it again just to tinker around with things, to do load tests, doing all that stuff. One of the things that caught my attention has been Docker. I really like it, and the reason for that is because I'm going to try to explain it. I'm sure I'm going to do a terrible job. But the difference between virtualization and Docker is the fact that every time you end up doing some type of virtualization, you end up getting your guest OS, right? You end up creating some guest OS, and then you put your libraries and your binaries, and then you create your application, right? And then you do the same thing. With Docker, the one thing that you have is a lot of things. It's a very thin layer that you have. So you end up having some type of host OS, but then the Docker is very small. One thing that I really like about Docker is the fact that you can build images, right? Let's say, for example, you end up creating some type of some type of Spring Boot app, right? Which has a Redis cache with the Postgres database, right? And by the way, I'm using Java 8 here. And that's fine. I want to create 3 of those guys, and that's totally okay. But then after that, I have another application that is using Java 7. And in this case, it's a regular Tomcat, right? That is actually using Memcache and it's using MySQL. The one thing that you end up having is that you can basically configure all these little containers, right? With just little bunch of plugs that are putting out. And then the only thing that you say is, oh, look, this guy needs Redis. And then this guy is also, needs Memcache or Postgres. And in my mentality, because I'm dealing with the stuff that is inside the container, right? I'm saying, you know what, I'm going to run everything in 480 because, it's the application. And once I end up fixing it and building it, I'm going to put it on production. And what you end up creating is the separation of concerns. Because the one thing that all this stuff, all these images are running in my machine, and also are running on the stage. But the one thing that you end up having is the separation of concerns, because all these guys, if you notice, I'm running, 2 containers over here, both run the same map, and there's another container, both running on the same map. And it's running on my machine with port 8080, and I'm okay with that, right? And then the separation of concern comes in when actually when the sysadmin says, okay, I see that this image has all these little plugs in there. I noticed that it has a Redis, it has a Postgres. So let me just pass the Postgres and the Redis via some type of environment variable to get, the correct production environment. And also let me change status because I'm using the same server and someone already has 8080. I'm just gonna, sort of like map this 8080 to the 99 and then do the same thing with this one. But one of the things that you get is like, it's really, really fast. If you haven't used it, I suggest you just give it a try, just so you can tell. It's one of the things that we're really looking forward to it. It has a compelling argument because of the fact that you can not only is very fast. This whole Docker thing started like about last year, if I'm not mistaken. It has probably a year, if that. There's some concerns that we have. And that is the fact that if we go back over here, one of the things that you end up having with Docker is that every time you end up creating all these little containers, right? When you SSH with them, you SSH directly as root. And if you notice, you don't have this guest OS anymore. So there's a security vulnerability there. And we're looking into that. They have a patch in there, but also they created a spin-off called Rocket. But the one thing that I know we end up noticing, we have a few of the architects going to reInvent, which is the AWS. Right now, AWS are also implementing their own container libraries in there. So I don't know if they tackle this whole security problem, but once again, the fact that we no longer have to worry about recipes, right? Because before, you end up configuring all this stuff through your recipes, right? But one of the things that you have to remember is like, oh yeah, I remember that. In this case, we need to export. I know that the configuration said that it's 8080. Now we need to end up doing like, this one 8080, but this one 8091. And here's a lot quicker. And the one thing that you avoid is the whole syndrome of like, it worked in my machine, right? You know for sure that that is going to work like that because one of the things that you're shipping is the entire image of the application. The only thing that you're doing over there is, like I said, you're hooking up like the different ports, and that one is done by the sysadmins. The other thing that we're leveraging a lot is microservices. We are heavily using Spring Boot. We started using Drop Wizard at the very beginning, and we really enjoy Spring Boot. The one thing that we end up liking with Spring Boot is the fact that it has so much of it already enabled for us, and we can create small little apps. If you haven't used any of the microservice, one of the things that we end up having at the very beginning of our application, well, when we started, right, we started as a PHP company, and then very quickly, right, end up getting really big customers. So one of the biggest customers is Redbox, and the other ones are Walgreens, right? We also end up doing a lot of IVRs for a lot of the jails over here in the United States. We hold the two biggest ones. So we have a lot of traffic. We do all the push notifications for also for, like I said, for Redbox. So one of the things that we end up having is this big monolithic application for PHP. And it's just hard, as we all know. It's very hard to scale. You got this ginormous thing, and then all of a sudden, like it happened to me, the moment that they said, "Oh, Marcelo, we need to edit or we need to modify this application," it was just a scary feeling because you have no idea what else is going to break in there. And this comes with the whole microservices, right? The moment, but there's no free lunch, right? You end up breaking all these things away. Now you have someone has to end up doing some type of coordination. And one of the things that we're looking into is, I don't know if you have seen a 12-factor app, right? That's something that we're also looking into it a lot. And that's the reason why we're also looking at Spring Web Services. They said that's Spring, I think no, Spring Cloud. So,
Cloud Foundry.
no, it's the Spring Clouds. What is it called? So anyway, so the one thing that you end up having, one of the things that you end up having with Spring Boot, right, is every time you create that, you create an application properties file. And that's fine, right? Imagine now you have two applications, and the only thing that you have to manage is the fact that, these applications now, they just have these application properties, right? If you go back to the model of, or if you go to the 12-factor model, you end up finding out that really doesn't scale, because now you have to keep in mind that you have to maintain these properties files or this application YAML file, right? So one of the things that you actually can also do, have some type of configuration services that can automatically detect, right? And then they can subscribe to a service and get all the configuration from there. And that's one of the things that we're moving into. I'm a big Scala guy. I really like Scala. I think it's great functional, programming is awesome. And there's another, this is not Spark, the Spark that is taking over the Hadoop world. This is Spark, the framework. Not to be Wichita, I'm also a fan of Spark, by the way. But anyways, I end up using Play. I haven't used Spark, but this is something that we're probably not going to use because we're a Spring shop. And I think that's it, guys. Oh, no, sorry. Server dependencies. We prefer REST over SOAP. And the difference is, and I heard this the other day, I prefer choreography over orchestration, which means that in SOAP, right, one of the things that you end up having is, the reason why you end up creating SOAP is because you have this enterprise bus that is coordinating these things for you, right? One of the things that we end up trying to leverage in REST is basically make it the semantic over endpoint versioning, and we also end up using a lot of HATOS, right? So one of the things that we end up trying to make sure is that we flow over REST instead of different endpoints, basically create some type of state machines, right? That they go, they end up taking a look at the whole hypermedia file, and they just basically jump through all those guys. So one of the things that we end up thinking up front is that whole architecture from the HATOS all the way to, down to like the semantics. Like that, let's say, for example, if I have a service and it's being consumed by someone else, I don't have to tell them the different endpoints, like, oh, this is how you end up creating, this is how you end up putting stuff in the chart, this is how you go to the checkout, and also this is how you end up checking your orders and all that stuff. The moment that you end up going to the page, right, the application renders automatically all the different endpoints that you want to get. And this is something that we really like. right? So again, we end up choosing REST because of that. Again, I talked a little bit about this, right? We try to get away from this, but it's been very, very hard. Mainly because not only we're doing a transition of continuous delivery, but because also, in reality, the company just started in 2006 as a startup with a PhD app. So things have changed a lot in 7 years, right? Being in the company for 2 years now, and it's just been hard because, like I said, even though I'm an architect, one thing that they do is, I go to a team, but they just have a dotted line to me. It's not like, I can fire them or anything like that. I'm just responsible for the architecture. But then, like the team will end up leaving, including myself, to another project. And then, there's a problem with the application, and then they come up to me. And then they were like, hey, something happened to this app. And I was like, I haven't touched that app in like 3 months, which in Marcelo's year, it's like 15 years. I have no idea what that error is. And so one of the things, and I got this from my buddy Juan at Amazon, is that if you build it, you run it, and you own it. Over there, they don't have a sysadmin. They just don't. And they take, one of the things that they end up doing is they get on calls, right, during the weekends. So they rotate themselves. And one of the things that they said is like, you know what, we have products over here. If one day I want them to work on another product, then I got to go to another team. But it's not like the team goes to another application and they just leave that project all by itself for the sysadmins to manage. And I thought that it was really cool because right now we're still managing, projects, and we don't manage products. So this is the summary. One of the things that you end up having is you want to reduce friction, right? One of the things that I tell people to put in their dashboard, or at least one of the metrics, should be how quickly you put stuff in production, right? And that doesn't mean Nestor and I were having this conversation. For example, different applications, right, behave differently. Of course, an application that is doing credit card settlement is not going to have probably continuous delivery, right? It's a huge amount of stuff that a lot of people are looking into it. So the velocity of getting into the production is going to be a lot lower than, say, for example, a website, right? That's just, and that's okay. But one of the things that we're trying to do in this whole realm of microservices is that, yeah, maybe there's other components that they can have a higher velocity, or probably they do have continuous delivery. For some other applications, they don't. They have probably a continuous deployment, right? And they have different velocities. But that one of the things that we want to do is reduce the friction. And one of the things that you get from automation is, like I said at the very beginning, engineering best practices. That's something that you get once you start doing this whole automation. One of the things that we've been trying to do, at least in our department, is incorporate everyone into the continuous delivery practice. It's not easy. Stero mentioned, it's something that you have to see it as a big investment that is really going to pay off at the end. But you really need to incorporate all these people and just rally them out. So one of the things that I've been trying to do is just that right now. Again, measure success for your cycle time, how quickly you can turn around, see if you're doing something good or bad. And as I mentioned before, metrics, I cannot just say enough about that. Make sure that you have thresholds, if something's happening, make sure that you monitor all of that and continue to improve. And I think that's it, guys. I don't know if you have any questions. Oh, thank you, guys. Thank you.
I have a couple of questions for myself.
Yes.
The first one is actually something that you mentioned like 5 times, right? You mentioned metrics all the time, and you're using several packages for that. I'm interested in knowing what are the top 3 metrics that you are currently measuring.
Oh, that's a very good question. At the very beginning, one of the problems that we end up doing, we decided the metrics. the development team decided the metrics. We thought it was a great idea. So we're doing things like, how many messages per second are we getting? How many errors are we getting? And then it was very quick for us to find out that we have to engage our clients, right? So for example, they didn't care. They were like, "Dude, I don't care if you settle that transaction like in milliseconds. I want to make sure if it's settled, right?" Or in another project that I worked on, we had an idea of what the metrics we wanted to have, right? But because of the lessons learned, we decided to just go ahead and ask the client. At the very beginning, we thought the same thing, like the engineering had automatically thought, okay, clearly you need to have some metrics if something goes down. Let me just be flat out there. System goes down, a node goes down, you need to be notified. But there's different metrics that you need to know if, this is the key index, if the services are okay or not. For example, in the example that I mentioned before, someone changed, the purchase button to Bro. Well, one of the things that you want to see is how your sales are, right? So one of the things that you want to have is sort of to see some type of bell curve, right? And find out like, okay, what is the statistical analysis of what our purchases are. If we go beyond that threshold, we need to find out what happens. So to answer your questions, it depends very much case by case on the project, but we basically get all the metrics that we need for the systems, right? Again, just to make sure that it's reliable, make sure that it's up to date, make sure that it's able to handle the load, but at the same time, we end up getting the metrics for, our clients. So again, if all of a sudden the sales are going down, we need to find out why, right? The way that I tell people is if our client calls us, the metric that I use is if our client calls and they become our call center, we fail. Right there, that's an anti-pattern right there. We know we failed. If our customer is being the one that's saying, platform screwed up. And that's it.
Okay, good, thank you. And then the second question is, how many developers your IT department has? Because you have described here such a big stack. And according to my experience, this is very difficult to achieve.
It is. We have close to almost 30 developers.
How many?
30.
30. Okay.
We have close to about 30 developers. We have developers in Boca Raton, and we have developers also in Eugene, Seattle, and we have developers also in Uruguay. In Uruguay, we're going through the whole transition of getting, there was a lot of the PHP developers there. Right now, one of the things that we ended up doing in our department was basically we put a stop on any new development with PHP. So we contain PHP. All new development is in Java.
And the reason for that, to stop PHP development was?
Scale.
Okay.
Scale. The reality is I never use PHP. But one of the things that we end up doing in our department, we got together with the business and we tell them, okay, we end up having some clear metrics from the company. The company had a vision. In this case, they were like X amount of dollars. We want to get X amount of dollars. To get X amount of dollars here, business, what do we need? And they were like, okay, we need this client. We're going to get in this field. Okay. For us to get that, what it turns into, transactions per second. And then we try to mimic that in an environment. We end up firing. PHP it could do it, but having, basically it would take about almost 4 times as much as a Java. So for us, it was like a no-brainer at that moment in time. That's why when I say we, there's only 4 architects in our team, well, including my boss, which is the chief architect, and that's what we end up doing. So again, once we end up firing that off, we put all the metrics and getting all the data, put it out there. We're like, yeah. At that moment in time, it was clear as that, like,
Yeah, the reason why I asked was that actually Facebook started with PHP and they still have PHP, but they have compiled PHP.
Yeah,
They
hip-hop.
have Swift, what is the
I
name?
think they use hip hop.
Exactly, that's the
Hip hop, but
yeah.
hip hop, yeah, it's funny, 'cause I had that conversation again with my PHP developers. One of the things that one of the experiences that I had, we end up running in hybrid. And so the funny part is that we end up running in a hybrid mode, and we said, you know what, we're just going to see how it plays out. We're just going to have the PHP developers and the Java developers, and for something that's super scalable, we're going to use Java. But something simple, let's use PHP. It just makes total sense. So what used to happen is that a guy would come in and we're like, hey, I need this app. This app needs to be right away because the client is expecting anyone to be the first one in the market. So then the PHP guys will come up and says, I can do it by today. By the end of today, I will be able to give you this application. And then the Java guys will be like, yeah, but then we have to fix it. And so it ended up being with this like weird dynamic and this holy war going on. It was until basically management, right? Actually, the business was the one that said, guys, we need to get here. And so we end up getting, at that moment in time, then we end up having a clear signal rather than all this noise. And it helped a lot. Well, I take that back. It was not 100% successful because clearly, those great PHP guys end up leaving, right? They end up seeing the writing on the wall and they were like, well, I don't want to write Java. I'm a PHP guy, so I'm going to go. And they left. The reality is that they left. We lost a lot of great guys. Some others stayed. I'm not saying that they were mediocre. Some of them, they were very good PHP developers, and they just wanted to learn something new. We ended up losing some people. But my personal opinion, at that moment in time, we had a clear signal. So it was a lot better in the long term, I think.
Over 30 developers, you have teams of like 7, 10.
We actually have 5 teams. We have 2 product teams, which is the team that is trying to chip away this big monolithic PHP app. So we have two product teams, and one of the product one of the main guidelines for us is getting to that 2,000 messages per second, right? So that's the metric that we're using, and then the other one, what was it? The other one, I forgot what was it. But I'm sorry, no, the other one is basically chipping away this big monolithic app, and the other one is make sure that we get this 2,000 messages per second. There's another team that the only thing that they're using is the payment, right? So anything that has to do with credit cards, we also end up doing billing through mobile phones, right? Then we end up having an IVR team and some other 2 teams there. But it's a big shop.
So when you talk about 30 developers, you're including there the architects, the DevOps, the operations guys, or those are just developers, really coders?
Yeah, we have some. We have definitely. No, what I'm saying is these are straight up developers.
Okay.
We do have. We don't have that many DevOps. I'm sorry. We don't have that many sysadmins. Unfortunately, we have about 5.
Okay.
Sysadmins, and we have about probably the same QA, which is a challenge, right? Because one of the things that we end up having, as you can imagine, is yes. So you have this, based on what I was mentioning before at the very beginning, you picture this amazing, developers, QA, and system engineers all in one product. How are we going to do that if there's only 5 engineers, 5 sysadmins, and 5 QAs, and yet we're running like this? Yes, there are 5 teams, but it's just a big team. So it's a challenge that we're looking at.
How about DBAs?
We do have a DBA team because we end up having 3 DBAs.
And project managers?
We have a lot. One of my biggest, there's nothing
Being
against,
recorded.
there's nothing against project managers. I really like project managers. I think that they're great. The problem that I have is overhead. I see this time and time again, and I don't know what it is. But sometimes what I feel is like if you give me a project manager, a product manager, a lady that is typing all the time, and she brings her own keyboard and the mouse, the only thing that they're doing is taking notes. Then you're not adding any value other than just keep asking questions and making meetings. Just don't like it. But we end up having, in a project that we're working on, we end up having 2 project managers. One Scrum Master, one lady that I don't know what she was doing, and a mediocre product owner. I'd say mediocre product owner. For me, this is something that I care about a lot. A product owner is the closest thing that you have to a customer. Bottom line. That guy is a domain expert. That's the kind of guy that is breathing across from you and they say that what I wanted was not blue. I didn't want blue. I want navy blue. I want navy blue, and it's this type of blue right here. If you put it right next to this, that's not navy blue. That's the type of guy. And if you ask him, like, why navy blue? They will tell you, like, for an hour, they will explain to you why navy blue is so important to the client. For me, that's critical. For me, that is a panic button that I have. If I don't have a good product owner, like I said, a guy that is completely the domain expert, my experience, you're set up for failure.
And you, as far as I understand, you guys don't have dedicated business analysts, right? Your developers basically discuss directly with business, and they will come up with the user stories and all that, right?
No. One of the things that we have for every project, we have a protocol.
So the product owner actually works as a business analyst.
Exactly. Yes, he is the one. Like I said.
So if you have four products today, you said that you have 4 products, right? Or 5?
No, 5.
5. So basically, you have 5 PAs there.
5. Well, we're going product owners.
So earlier, well, I have 2 topics, but really quick, you mentioned something about parallelizing.
Yes.
And then your diagram showed little arrows coming from unit test, analysis, and compilation. I don't know if you meant that you would actually be compiling at the same time you're running. No, right? But it's because everything has to be in one.
Right. Yeah. Definitely, you need to have the binary. So the moment that you have that binary, right? You want, like I said, this is something that we used to do. It was sequential. Right? You end up saying, I'm compiling, now I have the binary, now I'm going to run my unit test. I'm sorry, we're compiling, then I run my unit test, and I'm running my integration test. Everything passed, awesome. I'm going to package this guy, then I'm going to send it to Nexus. Once you finish compiling that, you can't mount these guys into a parallel. If something fails, it's like, it fails, you stop everything. Like I said, one of the things that we had is, putting it to Nexus was all the way to the bottom. And it was getting filled all the time, so it was like, what a waste of time. It would be nice to say like the Nexus is all connected up.
Yeah, I feel like an evolutionary. Eventually, we're going to get to, hey, I don't even want to wait 10 minutes. I don't even want to wait 5 minutes. I feel like parallelization is kind of the next step. Even from unit testing, it's like, can't we just run everything all at the same time? On whatever many machines, especially if we're in the cloud now, with let's say Docker, spawned all at the same time and then just destroy. I see it going in that direction for some reason, because even if you have end-to-end testing, performance testing, I just feel like maybe those things take a little bit longer, but even 10 minutes for me is like, I want my code in the environment right away.
The measurement that we end up doing. Sorry to interrupt, but the measurement that we end up doing is for unit tests, it has to be in seconds, max 20 seconds. it's taking more than 20 seconds, then we're
What
not-
about like median tests where you're
Right, so but
like
that's the-
in-memory database kind of
Right,
thing?
so that's when we leverage all this embedded stuff. Even like, for example, we use Cassandra, we use Kafka, but there's embedded systems for that. So we leverage all of that stuff in, embedded system. But then you go to the functional tests, and those one, we are all agreeing that will take a little bit longer. Because now, instead of testing out to make sure that there's no problems with the refactoring that you end up doing, now the one thing that you're doing, right, is making sure that the business rules haven't broken, right? They're not broken. So you end up, putting all these things in place where you actually end up getting a binary, and now you have some user acceptance tests, and you end up firing for like saying, okay, I want to log in, I logged in. I want to add stuff in my card. There's 2 guys in the car. I want to do remove one. I remove one. I want to do a checkout. So those ones take a little bit longer, and that's fine. We're okay with that.
My other question was about versioning, which I feel like
Oh man!
still,
Yes.
how do you coordinate all of the different components together in a version? Let's say you're even using infrastructure as code. Your server, in a sense, is kind of versioned, right? But still, and you might be versioning your database, you might be versioning your application, but still, when you make one single deployment or you're in one continuous delivery pipeline, you need to assemble all those together and pick the versions and know what goes with what, and then say, this is the one that's going, out of all of them.
Oh man, that's a great topic. I don't have the answer for you. We're still debating that because we're not talking about versioning numbers. We all agree, at least for us, we always follow the same rule, right? You have a main version, you have a minor version, and you have a patch, right? So that's like that 1, that 0, that 1, right? But then you end up bringing a very interesting topic, right? You end up getting all these microservices, but at the end of the day, you want to tell the customer this is version X. At the very beginning, the way that it has worked for us, we tried to do it like a version like that. We failed miserably. We failed miserably because of what you said. I have this big application and it's using 1.0 here, 2.0 there, 1.1.1 here, but all of that, we call it Captivate.
I envision it's like you just have one file.
Yeah.
It's like a manifest file in a sense, and whatever one, and maybe it's automatically updated from some kind of pipeline or whatever, but literally that version, it's like a version of versions, like a scrum of scrums.
It's not
it's
even
like,
like that.
like it just shows everything, and that's what's used to deploy.
The way that we're doing it right now is there's a Confluence page, and they were like, Confluence 1. Then it has, transaction gateway 1.1, IVR 2.2, Sentinel 3.1, text for 2.0. So it's like this disparate thing. One of the things that we're talking now more and more is the fact that we're now looking a little bit more at the microservices. And one of the things that we end up getting from Netflix is that they're saying that you should decouple your database completely, right? Yeah. And so that microservice should have its own database. That's something that is still, I feel in my belief that we're still trying, at least in my company. We were big, LAMP stack before, so we have a big footprint on MySQL. And many of the developers, that we tend to go with bad habits. Automatically, we're like, let's use MySQL. We have this ginormous machine over there that is MySQL, but not putting it there. And, so we've been leveraging other.
You can't have two microservices that all use the sharing.
Yeah,
that's kind of breaking the pattern of it. Otherwise, there's
that's the anti-pattern that I mentioned before, where you actually end up having this application and then you have all these dependencies on that database. So it's you're no longer continuing the deployment because now you have that dependency. And we're still going through that pain right now because, like I mentioned, Transaction Gateway, which is an application that we use a lot, in processing credit cards. bunch of reports and bunch of application and a whole bunch of stuff is being made there. So we call it the bicycle of the village. Everyone had a ride. So, but anyhow, yeah.
Oh, I got some questions.
Oh, please, yes.
Hey, it's about like what you're saying about the versioning, what I call distribution server.
Yeah.
I mean, you have to have a point of download, I mean, maybe you're using Nexus, maybe you're using Artifactory, maybe you're using some other service, maybe an FTP server, or I mean, what is technology are you pulling down for all these just separate services,
Nexus.
Nexus is, so you have a Nexus server that's basically a service outside.
Yeah.
And then all the AWS and in-house standalone services all pull from the versions when you get your script.
Yeah.
To build a Docker, whatever piece.
Yeah,
you want.
we're not using Docker right now in prod. Right now, what we have is a bunch of recipes that are basically doing that. Right? They're like, okay, I'm one server X, and the server X is going to have, this version, right? So, and it's also going to have this configuration file of this application, that property is in there. And also it needs to have this SSH certs in there as well. So it has all those recipes there, but yes, they're actually pulling from the Nexus.
No, it is AWS, right?
Yeah.
So it's itself, the Nexus server, you're saying, right?
Yeah, that's what we put over there.
So it's interesting that you say about Puppet because you seem to be a programmatic shop, and a programmatic shop doesn't usually go with Puppet. From my understanding, it goes with Chef because Chef is more programmatic.
It's something that we're also fighting. One of the things that we're using also is OpsWorks. I don't know if you guys been using OpsWorks. AWS has this amazing thing that is called OpsWorks. OpsWorks is actually one thing that you can end up doing is you can end up creating layers. And so you end up creating, for example, your service layer, your database layer, and all of that. But right now, today, the only way that you can manage all of that is through some type of check recipe. So us architects are going through the cloud and trying to see if not only we try to see how we can get stuff into the cloud, but also see what stuff is out there that we can leverage, some of the tools that we have. And right now, Chef is the dominant one. Chef is very dominant. But sysadmins, they prefer Puppet.
Right, of course.
Of course they do. So, and the funny thing is, I feel like it's like my buddies from Oracle. Like, you tell them about any other database, and they all suck. And it's like the same thing with my sysadmins. The sysadmins, I'm like, what about Chef? They all suck. Because why? It's not Puppet.
Because they have to code it. They don't want to code.
I don't know. So, geez, we still have that. To be quite frank with you, I prefer Chef.
Ansible. You tried Ansible?
Yeah, I heard that Ansible was pretty cool. I like Chef. It's just because of the fact that, as I mentioned, AWS leveraged a lot from Chef. And I don't know, there's one of the things that, to be fair, I think that the poor guys, the sysops, they just got a bad rap. They were always considered like the bottleneck guys, and the guys that were always imposing all this different governance. So, everyone hates them, but now, being in their shoes and the fact that we end up doing this stuff, I understand. I would do the same thing. It's that whole saying, the beating will continue until morale improves. That's how they were. All of us were used to putting the finger at them and say, please, you're the one holding this whole thing down. We could deploy yesterday, but no, we can't deploy it on Friday. So I think that now we're working together. The fact that we're working together, we're breaking down those silos. And now, we're not only learning a lot of stuff from them, they're also learning a lot of stuff from us. So at the same time that we're learning how to, do things right, with our logs, At the same time, we're making sure that they see, the difference of having chat versus Puppet, to the point that they're saying, it's the same thing. As long as we manage the infrastructure as code. But we're slowly getting in there. The reality is that we made a huge investment in Puppet, and a lot of our modules are already there. So it's going to be a huge endeavor for us to all of a sudden, pull the plug and say, screw it.
For 2 years, it looked like Puppet was going to be it. And
Right, and there's a lot of people used to say that I don't want to be into chat because it's too much like Ruby. I have to learn Ruby. I like Ruby.
So when we have like PCI compliance, we just finished our PCI compliance, and the introduction in my company for the operations team coincided with our first PCI compliance, because one of the controls of PCI compliance demands that you have a separate, no developer has access to production.
Yeah.
No developer can push stuff. Everything has to go through a process, and then the ops team is the one that actually has the fingers in production.
Mm-hmm. Yeah, you do the same thing with Sargon actually. Yeah. What is it called? Socks. Thank you, socks.
But continuous delivery is really set up for that. I mean, you can literally, if you're automating everything, now you have a complete audit trail.
Yeah.
Who did what and where, and then you're going to, okay, maybe is it really limiting the developer from pushing the button, or is it more of a checks and balances saying, hey, I built it, maybe this other person should be deploying it? Because now you don't have to have direct access to a server. You can have some mechanism that is going to deploy. It's not like you're going into a server and logging in, but there's a lockdown, secure deployment that's deployment script or deployment, I don't know how we deploy it.
And that's the difference. So the way that we end up doing it is compliance, which will be our QA team that, understand all the PCI compliance. They're the one that push the button. But, so in that case, we don't do continuous delivery. I'm sorry, we do continuous delivery, we don't do continuous deployment.
Right. So yeah, it's
Right.
Guys, I need to run. I'm sorry.
But yeah, thank you so much. Thank you. It was
Awesome
great.
talk.
Oh,
Thank you.
thanks. So yes, it's the difference between having a pull versus a push. Someone is actually pulling that stuff over to production, and that someone is, the way that I see it is continuous delivery is continuous deployment with compliance.
And what about, you mentioned, as far as I know, you guys are Scrum for all the methodology, there's no Kanban?
Yes, actually, we are looking into Kanban. My team is now using Kanban, mainly because we got it from you.
So you helped do Scrum band?
Yeah, we actually started doing Scrum band at the very beginning, because first of all, we didn't know much about Kanban, and the other thing was, but anyways, the way we stumbled with that, it was toggled. The moment that you end up creating some type of story to create this feature, and the fact that we didn't want to put it on production, right? You end up creating a toggle for that, right? But at the same time, you have to create this technical debt, say, at some moment in time, I need to merge it, I need to remove this toggle. So then we're like, Daryl said that because they were like, so why do we do it? Do we do it this iteration? Should we do it? Because if we put this in production, everything's okay, we can remove it. And then I was like, huh. So Daryl said,
Limit of 10 or
Yeah.
something, or
yeah, so then we're gonna have some type of threshold, right? And the one thing that we also end up doing is, Kanban, so like that. We have to take that the moment that we end up finding out that everything's okay, then we do it and we merge it. And that's how we can do it.
I don't know if you guys know, but in May is going to be the big Kanban thing in Miami. Yeah, so Lean Kanban is coming back. The first conference was in Miami in 2009, and they're doing it again this year.
Cool.
So yeah, so 3-day thing in May.
Sweet. May?
In May, yeah, in May. And Mr. Anderson will come down here along with his.
Every time I hear that name, it reminds me of the Matrix. Mr. Anderson.
Mr. Anderson, yes. Mr. Anderson is coming.
Dude, I don't even know if we got some questions.
On the thing, maybe.
This is so meta. So I'm gonna stop you to
Things.
You know what I'm saying? This on the left side here, there's Q&A.
And it's completely, like you said, a minute.
Okay, I'm sure
Each
that helps.
different stage.
Yeah, at least I go.
Okay,
So
good.
like.
Good.
Only one program, so I can only.
So I'm going to